Today, I'd like to talk about the transform 2D node. Now, we've used this guy a lot, whether it's changing angles or sizes or offsets. But one thing we haven't done is actually use input parameters to get this stuff done. I mean, it's easy for the offset. It's got its own function here. But the width, the height, and the angle actually share a float 4. And we could put incredibly complicated functions in here that will do pretty much anything to this 2D image. If you can express it as a function, you can make it happen because you have control over all those points, the width, the height, and the angle, and you have control of them all at the same time. We're going to start small. First thing we're going to do is just wrap our minds around how this works. Now here we've got this matrix versus edit button. And this is exactly the same information presented in two different ways. And if we switch back to the matrix and we start turning this, we can see that all the moves we make are actually translated to this float 4 value. And it's this float 4 value that we manipulate in this function. And initially it's kind of a bit of work to wrap your mind around how to do this because we've got it all set up here where it's separated out for us, where the angle is separate from the width and it's separate from the height. But in reality, what we've got is it's actually just one matrix. And for that reason, we're going to start slow. I mean, basically what this means is that if you can write the function, you can get this image to do anything you want it to do at any time. And like all this stuff can happen at once. So you can have it like tumbling through space, like a 2D image that is literally animated by a function. But today we're going to keep it simple. And we're going to create a little node that will take a black and white input, and then we'll rotate it counterclockwise, clockwise, and 180. And it'll also be able to resize the image and set the kind of tiling mode it's going to use so that it can use either just horizontal tiling or vertical tiling or no tiling. And what this will allow us to do then is reuse it as a mask in something else that we make. But more importantly, it'll serve as an exercise in how to start thinking about using functions to mess around with this matrix. So I'm going to grab a new one of these guys. And let's take a look at what happens when we turn this 90 degrees clockwise and 90 degrees counterclockwise. So this is the default. We've now switched these numbers around. And let's turn it back. And we'll switch back to the matrix and take a look at what's going on here. This x1 value talks about how many of this image we can fit along the x-axis. So as this number gets bigger, the width becomes smaller because we can fit more of them. This last y2 value is talking about how many of the image we can fit along the y-axis. And between this width and this height, you can, for example, set tiling modes if you make this integers. There's a bunch of different things you can do here. This number is talking about angles. Now, these numbers are moving as well because we're actually, as we're changing this angle, where these numbers are, where those points are, is also moving. And that's why we're going to stick to really whole numbers here as far as the rotation goes, because it's a little bit too much to start dealing with it all in the beginning. But what we are going to do is we're going to create float values that are going to correspond to this number and to this number. So it's going to allow us to size it. And if we turn it by whole numbers, it also allows us to just do those cardinal turns. So 0, 90, 180, 270, and back to 0. So let's start with the rotation. I'm double clicking on my transform 2D. I'm going to come into here. I'm going to go into my matrix. And I'm just going to create an empty function here. And the first thing we're going to do is get a float 4 and make 3 copies. And we're not going to use this for anything, but I find it very helpful to use this as my quote-unquote notes for what my setup is. So this is going to be my default. And we've already seen this. This is a 1, 0, 0, 1. I'm just going to fill these in for you, but you could get to them by experimenting yourself and just going through the various default turns that it gives you and see what it comes up with. So this is a clockwise turn. This is a counterclockwise turn. So you're kind of seeing a pattern developing here. And our 180 is 2 negative 1s. And we can see that, each of these is a negative of the other. And by doing it this way, it kind of helps you wrap your mind around it. And it's also going to make it much easier for us to build our function, because we can just refer to our little clock here and it'll tell us what we want. And right now we could turn this thing around just by setting each of these as an output node. And that confirms that we've got those directions correct. Okay, so to build our function, we're actually going to need to create an input parameter. And we'll call this orientation. And this is going to be an integer. And we are going to make a drop-down list. 0 we can have as 0 degrees. We can actually leave that alone. 1 we'll have as 90, 180, and 270. And we've got the default, which is this check mark, is set to 0. And now let's come back to our transform matrix. So we'll get our variable integer. And now we have to figure out how we're going to set up a function that's going to result in a float 4 value that's going to turn this integer 0 through 3 into one of these guys. And we're going to do this with a comparison. So if orientation equals 0, which is the first number in our list, these are the 3 numbers we're going to need in here. So if orientation equals 0, then I want this set of numbers. How are we going to make them? We're going to make them with a series of if-else statements. So I'm going to duplicate this out 3 more times. And this series of if-elses is going to correspond to my x1, y1, x2, y2 values. They're all going to have the same condition. So if orientation equals 0, then I want my x1 result to be 1. I want my x2 result to be 0, my y1 result to be 0, and my x2 result rather to be 0, and my y2 result to be 1. Otherwise, I'm going to leave, I don't need an else here. It can stay null. If it's not 0, we're going to let it move on to the next thing. I'm just going to copy that and I'm going to paste it. And I'm going to get rid of these results here simply to avoid confusion. And now we're moving on to the number 1. So if orientation equals the number 1, which is our, I forget, let's take a look. Number 1 corresponds to our 90 degrees, so that's clockwise. So if orientation equals number 1, then we want what's going on in here. So our first one is 0. Our next is -1. The one after that is 1. And then the final one is 0. And if it's not this, we're passing through these results. And we can do it again. So I just repasted that out. Again, I'm going to get rid of all of these things because it's confusing. And we'll now work on number 2. So we're going to need to add a couple more constants for that. So if orientation equals number 2, then we're going to want 180. So here we have -1, then 2 zeros, and a -1. And one more time for the number 3. Oh, we forgot to pass these through. So here we're going to need a 0, a 1, a -1, and a 0, and pass the previous results through. And what we've done here is create this daisy chain where it's just running through the various available integers. So it's starting with 0. If it's not 0, it's asking is it 1. If it's not 1, it's asking if it's 2. If not, it's asking if it's 3. And those are all the various possibilities. And we end up with this row of 4 if-else statements at the end. And now we vector them. So x1, y1, x2, y2, and they get vectored into a float 4. And then we're going to set this as our output node. And the test is going to come in here when we come back into our input parameters and we start messing with our default. And look at that, it works great. So we've fixed it so that we can now rotate. Well, it's not rotating where it's changing its orientation, which is different. Rotation is a lot more complicated. I'm going to try to organize these a little bit better. It's spread out, but it's actually pretty straightforward. But I want to get these guys separated out because the next thing we're going to do is we're going to start working on the width. So we're going to start working on this stuff in here. And we're going to be able to set the number of images in the Y and in the X. Right now, if we come in here and change the orientation to something else, that works great. But if I come back into my transform 2D and I start messing around with it in here, it's undoing all of that. And you'll notice it also undid our function. It cleared the function out. Yeah, my substance crashed, so I hadn't saved it. Let this be a lesson to everybody that you should save it more often. I've rebuilt what we did. It might look a little bit different, but it's the same thing. Anyway, let's move on. So we need to figure out a way of moving this stuff within this transform matrix. And the first thing I'm going to do is I'm going to create a couple more input parameters. I'm going to do an adjust horizontal. And I'm going to do an adjust vertical. And we'll leave these as float ones. Let's set the value to 0. Now, actually, let's set the default to 1 and the minimum to 1. And we'll set the maximum to 3. Because if we want to get it smaller, the number goes up, it doesn't go down. And 0 is going to give us a null value. And once we start going under the number 1, that means our image is getting bigger and it's going to start coming out. So if you want your image to like take over the whole thing, then you can let it have lower numbers, but I don't really want to do that. So that's why I'm setting it this way. So now we have these two input values, and all we have to do is replace them in here, and we'll be switching out these 1s and -1s, because right now it's the same number that's going to both our x and y value, and we're just going to have to separate that out. So we'll get two variable floats, and we'll have one as our horizontal and one as our vertical. And I'm also going to get a couple of negate nodes, so we can have negative values of that as well. And I want to go back out here and actually take a look at what we're doing before I start plugging things in. It'll help it make more sense. I want to take a look again at what happens when I shift things around in a transform. So let's say right now, our matrix is that original 1, 0, 0, 1. If we change this number, we get more in the x. If we change this number, we get more in the y. But let's see what happens when we take this image that we just made and turn it by 90 degrees. Those same numbers have now been switched out. And we have more or less the same thing happening again, only it's negating it in the same way that it's happening here. So what this is telling us is that we're replacing our x values in here. Well, the zeros we're leaving alone. The x values in here we're replacing with what's going to be coming off of this variable, and the y values will replace with what's coming off of this variable. So this is our x1. It's getting a whole number 1. So I'm going to use that one. These two are zeros. Here our y1, our y2 rather, is being replaced by a whole number. This is my y value, and I have it as a negative number, so I'll replace it here. This is my x value. It's a positive number. I'll replace it here. This is my x value. It's a negative number. I'll replace it here. 0, 0. And this is my y number. It's a negative value, so I'll replace it here. This is y. This is x. And that's a 0. So I'm adjusting on the horizontal. I'm adjusting on the vertical. I turn it 90 degrees. I'm adjusting on the horizontal because remember it's flipped it around. So this is now the horizontal. And now I'm adjusting it on the vertical. The same thing is getting applied to my 180. Because what it's doing is it's turning these values along with the orientation. And 270. So that's my horizontal, and that's my vertical. So now that's our rotation and, well, I shouldn't call it rotation. That's our orientation and sizing done. What I still want to do is to set the tiling mode on this. Currently, it's set relative to input, which is the default. What I want to be able to do is to change this. So we have horizontal tiling, vertical tiling, no tiling, and H and V tiling. And if we come in here and see this empty function, we'll see that the expected output type is an integer 1. I'm going to go ahead and clear this for now. And that means that we need to create an integer 1 parameter with a drop-down list that corresponds to what's going on here. So this is 0, 1, 2, and 3. We'll go ahead and make that. So 0 corresponds to no tiling. So we've recreated this drop-down. And it's important that it's set to absolute because it needs to be set to absolute in order to get its information from this function. Otherwise, it'll be overridden by either one of those two. And now it's just a question of exposing that. And if we come back in here, we can change the tiling according to our drop-down list. The other thing I want to do is be able to offset it. And again, that's super easy because we're just going to make a new parameter that we're going to call pan. And that's going to be a float 2. And we'll set the default to 0. And we'll fix it so that we can pan it in either direction. And we'll come back to our transform 2D and we'll set in pan. And at this point, I have all of the various things that I'm going to be putting in place as far as being able to manipulate this little image. And if you want, you can even take it further by adding an input in here and replacing the bitmap here. And if you create an input variable, this can then be reused in another graph that you make. And so we now have this transform 2D node, which is computationally a lot less expensive than, say, a splatter node or any of those other nodes that you would use to adjust things. And you've created for yourself this tiny little engine that only does these very basic things, but it's not carrying a heavy computational load. So very often I'll make these teeny weeny little things that do very simple manipulations, and then I'll just reuse them. So I hope that's helpful. You can take this and just run with it. Once you've figured out how this matrix works, you can pretty much do anything with it. So it becomes a very, very useful thing to know.